Nature, a place of wonder, magnificence, and beauty that cannot be experienced within the threshold of a home or the confinement of a high school. Spring recently started, the weather has been warm, and springtime activities commence. Why not kick off the spring with a fun pastime, camping? Our first objective was to find a suitable place to set up camp, and there's no place better than Kyle's backyard. We have decided to use what we have learned through this multivariable course to calculate the maximum number of certain items that are able to fit in a camping bag with a limited volume, as well as the area that our campsite occupies so that we can meet the requirements for the campsite with a limited amount of space. We will be bringing along with us some essentials like a tent, water, and food. We will use techniques such as triple integrals to calculate the volume of the camping bag and double integrals to calculate the area our campsite takes up. We then proceeded to set up a point of origin and label the X, Y, and Z axis on his backyard. We then used measuring tape to measure the length of the yard for the x-axis, the width of the yard for the y-axis, and the differences between the highest point and the lowest point of the yard for the z-x coordinates. The y-axis throughout the yard has no discrepancies. It can be characterized as flat. Only x and z values have changes to them, so only variable x will factor into the z equals equation. For the x values, we used increments of 50 inches as our x scale. X values range from 0 to 600 inches. For the z values, we first measured the difference in height from the first x increment and the origin, then the second x increment and the first x increment, and so on and so forth until we were able to generate a table of values. We then harnessed the power of the TI-89's graphing utility, plugged those table of values in, and were able to generate an equation. After plugging in all the points into the TI-89, this is the formula it generated for us. Roughly, the shape of our campsite would be a circle, and the reason why will be explained in a later part of this video. The tent, right now, is in theory supposed to be a perfect semicircle, so first we measured the radius of the tent. The reason our campsite is a circle is because the circumference of our area is a sea bear circle, a device that protects us from sea bear attacks. We extended the radius of the campsite by measuring the distance between the circumference of the tent and the circumference of the sea bear circle, and adding that distance to the initial radius of the tent. Our campsite now becomes a circular shadow on our plane, or the backyard. So the circular equation of the land around the sea bear circle and tent becomes x minus 400 squared plus y squared equals 65 squared, or 4,225. This can be broken down into plus or minus square root 4,225 minus x minus 400 quantity squared. Now the fun begins. We then use the surface area formula we recently learned to calculate the surface area of our campsite. We then took z on to the other side so we can get all variables on one side. So we found the gradient by taking the partial of x and the partial of z. Now we find the magnitude of the gradient. To find p, we have to take the vector orthogonal to the shadow. In this case, since the circle is lying in the xy plane, the orthogonal vector would be k. We then take the dot product of gradient f and p, and we take the absolute value of that, which gives us a value of 1. We will be integrating first with respect to y, then respect to x. Our y bounds will range from negative square root 4,225 minus x minus 400 quantity squared to positive square root 4,225 minus x minus 400 quantity squared. And our x values will range from 335 to 465. Combining everything together, we get this integral. The final surface area of the campsite is 13,275.2 inches squared. The book bag we will be taking with us on this trip is the normal JanSport book bag. For this book bag, we're going to assume that all the pockets are boxes. When taking measurements for the first pocket of the bag, we got the width as 7 inches, the length as 11 inches, and the height as 17 inches. From this we can form a triple integral finding the volume of the first pocket. For this integral, our integrand is going to be 1, and our 3 bounds are going to be the corresponding x, y, and z lengths we measured. This will get us the total volume of pocket 1, 1,309 inches cubed. We then calculated the volume of a tent in a bag in a similar fashion. We then calculated the volume of a single water bottle. Then from the total volume of the pocket, we subtracted the volume the tent occupied. From that we got the remaining volume that a certain number of water bottles could fill up. We divided that number by the volume of a single water bottle, and from that we concluded that 1 tent and 8 water bottles will fit in the first pocket. Like the first pocket, we calculated the volume of the second pocket and determined how many water bottles we can fit in there. Like the second and first one, we calculated pocket 3's volume. We then calculated the volume of a marshmallow bag and deduced that only 1 marshmallow bag can fit in pocket 3. Congratulations, you just prepared yourself for a wonderful camping trip.